Let us now consider the cost of labor. The first year, or rather 0th year, will have the cost of labor at $18.5. So it's equals B13. The next formula is similarly to the cost of board foot material equals the previous price equals D21 times parentheses 1 plus 1.5%. 1.5% is 0.015, so 1 plus 1.5% is 1,015, and it takes 101.5% of the previous price. We close the parentheses. We need some dollar signs here, so let's go to B14 and let's click on F4 key, and we have this formula. And actually, since we don't want to copy this labor formula to the left and right, it can have dollars all the way, so to say. So it's always fixed at 1.5%. But the blue cell, that will move. So if we copy it, here it is. The blue cell takes always the previous price. And actually, something we've seen here is we have such a table that progresses from up to down and always uses the previous value. This is something that very often comes about in Microsoft Excel. Okay, so here we have a address without any dollar signs and address with both dollar signs. Now our next goal is to take the price of the entire bookshelf, and it goes like this: equals 30 board feet for making a bookshelf out of cherry times the price of that board foot on the current year, so on the 0th year. Here it is, and it's going to be the cost of material plus 16 hours that we need for producing one bookshelf times the cost of labor, or the wage of a worker for that year again. So up here these two were always the number of board feet, the number of hours, but down here we took the current year's cost, So we have the correct cost for that bookshelf. Okay, now let's add something else. We need the franchise cost as well. So let's take the $1, and at first sight it seems that our bookshelf is ready. Well, for that 0th year it is ready. So it consisted of 3 parts: the material cost, the labor cost, and the franchise cost. Now we have to copy it to up-down direction, left-right direction, so that one formula will do it all. And we will see what's gotta move. B5, the blue B5. This one will have to move left and right. But it cannot move up and down. So right now actually cherry and oak have the same number of board feet, but it theoretically could differ if there is a statistical difference that one material needs some bigger losses percentage, for instance. So they could differ. So what we want the B5 to do is we want it to move left and right when we copy it to oak, but we don't want it to move up and down when we copy it to next year's. So what we do is we press F4 until we have B$5. The dollar sign is only before 5, so that it doesn't move up and down. It will move to the left and right direction. Okay, B21, will that have to move? That will actually have to move up and down because it's taking the next year's, and it's going to move actually to oak as well, to left-right direction, because we want the same formula to go for oak. So this B21 will be without any dollar signs. Okay, now let's take the B6, which is the 16 hours up here, and with that we want the formula to for B6 to move to the left and to the right, but we don't want it to move up and down once again when we copy to the next years. So we press one more time F4 key until we have $6. The next thing we want to do is consider D21. D21 is the, well, if B6 was the number of hours, then D21 is how much 1 hour will cost in the current year. So, well, it has to move up and down here to the next years. But actually, it doesn't have to move left and right, because when we copy the current formula to Oak, it still has to take the labor cost from the same D column. So we press F4 until we have D, dollar only in front of D, $D21. It moves up and down, 22, 23, 24, but it doesn't move left and right. It stays on D. And the very last thing is that franchise cost, $1, which doesn't have to move anywhere. We copy it up and down, it stays the same. We copy it to Oak, it stays the same. So we press just one time F4. And we see that this formula is actually the most complex we could have imagined. It has, let's say, one example of dollar only in front of 5, which means that the cherry 30 board feet doesn't move. So the dollar is only in front of 5. Then it has neither dollars. For instance, the cost of cherry's board foot has to move down for next year's, and has to move right for Oak. Then there is dollar in front of D, which is true for the labor cost, because this has to move up and down for the next years, but it cannot move left and right if we copy it to Oak. And finally, the franchise cost will have both dollars, so all the options are here. Now let's copy the formula. Once again, we copy it to the down, and then we take the entire column and copy it to the right. Here it is. And here it is. The formula works absolutely correctly. And now we know that at the end of the 6th year, or year number 6, counting from 0, we have the costs at $577 and $467. And it began from 516 and 426. And now let's graph those out. Let's just select these cherry and oak numbers and do insert, and usually when we have like two different dynamical values going up and down, we use line chart. So here it is, the line chart. We insert the line chart for different values comparatively, and we have to select, for instance, if we're taking from the first row where there are no markers on the dots that are exactly on the year's numbers, then we have to take the first column here, namely the, let me just do this over again, namely the first column lets the lines to intersect if we need them. So if one cost outpaces the other, then the lines can intersect. In the other case, in the second column, the lines can never cross each other, so that's not good. Of course, we could have chosen the first column and second row, so this has such dots marking the different years actually. So here it is. Our graph is ready as well, and we'll picture the dynamics of the costs.